At the end of this lesson, you should be able to analyze a graph for a correlation in the set of the scientific data. Correlation, if you break down this word, co is meaning between two or more things, or two things, and relation, the relationship. And so for our purposes, we are looking for a relationship between, and the two things that we're looking for a relationship between are the independent and the dependent variable. So if you look at this first box here, and we're going to turn this box into a graph where this is the x-axis and this is the y going up from here. And so the data on here has been plotted for us, and sometimes instead of referring to this as a line graph, it's better referred to as a scatter plot, because not all data points make a straight line. This one does make a relatively straight line, but that's not always the case, as you can see as we go down the page. So if the scatter plot, like this one, shows a positive correlation, that means that the data points are rising up and to the right. As you go across the x-axis, the data points are rising up. That's called a positive correlation. And what this tells us by analyzing this is that the two quantities are increasing together. So in other words, as the independent variable, which is on the x-axis, as it is increasing, the dependent variable is also increasing. And a good example of this is the relationship between smoking and cancer. So if this were smoking, this is the amount of smoking, then the dependent variable, if the more you increase smoking, the greater your chance of getting cancer. So this would be cancer incident. Okay. So if we see this pattern on a graph, we know that they have this positive correlation. As this increases, the dependent variable is going to increase as well. Let's look at the next example. X versus Y tells us that we are comparing an independent variable to a dependent variable. And in this case, the data is falling down as it moves to the right on the x-axis. This means that the correlation here, the scatter plot, is showing a negative relationship or a negative correlation, which means that as the x variable, independent variable, is increasing, the other quantity, which is the dependent variable, is going down. It's decreasing. That's their relationship. If this goes up, this one is going to go down. And so a good example for this is brushing your teeth. If the independent variable is the number of times you brush your teeth, then a good dentist will tell you that if you increase the number of times you brush your teeth, you are decreasing the number of cavities that you are likely to get. So this is number of cavities. So if you plotted these two on a graph, you would probably see a negative relationship or a negative correlation. As you increase the independent variable, the dependent variable goes down. Now sometimes you do an experiment and you get data that looks like this box. The x again has the independent variable on it, and the y has the dependent variable. So if you get data that looks like this, it tells us that the coordinates are plotted here are just random. You've got random data points. So a scatter plot will show no correlation when no pattern is appearing on the graph. If everything is just random, it's no relationship. It means that your independent variable is not related at all to your dependent variable. So I don't know, this could be anything like the number of times you play piano versus how many cavities you get. And we know that playing piano is not related to your dental health, so you would likely get a graph that looks like this. Okay. You can also show how much of a relationship you have between two variables by how close together the data points are to forming a line. So if the points nearly form a line, then the correlation is said to be strong. And so looking up here, there's a very strong correlation going on between the independent variable and the dependent variable. Smoking is the #1 cause of lung cancer. So they are very closely related to each other. All right. If the points are dispersed more widely, but still form a rough line, the correlation is still there, but it's said to be weak. And so box number 2 shows you a weak correlation. They are close to a line, but they're not. All the data points are not following exactly on that line of best fit. And so, like if I took a piece of spaghetti here, and this is useful sometimes for finding your line of best fit, you want to place the line of best fit where it's going to be evenly in the middle between all the data points. So this would be where I would place the line of best fit on this one. You can see that some of the data points are not exactly on that line. Where in the first example, almost all of them will touch the line. So this is strong correlation. And this one is still a linear correlation, but it's weaker. Okay. They give you a hint in this box that you can visualize whether it's strong or weak by imagining enclosing the plotted points in an oval. If the oval is thin, then the correlation is strong. If the oval is flat, then the correlation is weak. So the fatter the circle gets to enclose all the data points, the more weak the correlation is said to be. On the other side of this page, you have some independent practice here for recognizing correlations. And these are the types of problems that you're going to have on the quiz. You're going to be given a graphical model here, or a scatter plot, and you're going to be asked to describe it based on whether it's linear, nonlinear, positive correlation, negative correlation, strong correlation, or weak correlation. So looking at the directions here, first you want to draw a line of best fit for each of the scatter plots, and you're only doing this on the ones that show a linear relationship. If it's a nonlinear relationship, that means you probably need to draw a smooth curve instead of a line of best fit. So let me just show you 2 of these. The first one here, I know it's looking like it's going to make a line across the graph, so I need to draw in a line of best fit. I'm just going to use my spaghetti here to do that. Draw a line of best fit. I know that this is linear, so I can describe this first off as being a linear correlation. I also know that these dots are pretty close to the line of the best fit, and admittedly I could have drawn that a little better. But I'm going to describe it as a strong correlation. And then there's one more word that I can describe this correlation with. My data is falling downward as I move across the x-axis. So I know that this is a negative correlation. Now looking across my examples, there's one that I can very easily say is nonlinear. And so instead of drawing a line of best fit in here, the pattern or the trend that I'm seeing here is more like a cycle, like a heartbeat. So this is a non-linear correlation. There is still something going on with the independent and dependent variable here. They are related in a way that's showing a pattern or a correlation. But in this case, the correlation is non-linear. All Alright, you have some words here that you can choose from to do your practice. And I'm just going to break these down a little better for you. You're either going to describe these correlations as no correlation, positive linear correlation, negative linear correlation, or nonlinear, and then you'll go back and describe them as either strong or weak. So at this point, you want to complete your practice work before you do a self-check.